Okay, so now we're moving on to the last example of 3.5, linear programming. Now this one gets a little trickier than the one with external and flash drives because of where the point of intersections are once we graph and we look at the feasible region. So your calculator is one way that you can get around the difficulty that we're going to find here. Okay? So the problem we're going to look at, you sell mixed nuts and roasted peanuts for a fundraiser. You want to buy no more than 500 units and spend no more than $600. How should you order to maximize your profit? What is your maximum profit? So what we're looking at here for the objective function is profit. Okay? So just like before, I'm going to start off with objective function, and we're looking at the profit. Here's the information for each one. When they say 12 cans per case, 20 packages per case for the mixed nuts and the roasted peanuts, these are the units. Okay? Each case has 12 units of mixed nuts and 20 units for the roasted peanuts. Okay? You pay $24 per case for the mixed nuts, $15 for the roasted peanuts. Now this is how much you're selling per person. We're not going to worry about that too much. It's how you would find your profit, but we have our profit right here. $18 per case for the profit for the mixed nuts, $15 profit per case for the roasted peanuts. So that's what we're going to use for our objective function. We want to maximize our profit. P equals 18x plus 15y. Okay, and we haven't stated this. X is going to be our mixed nuts. Y is going to be our roasted peanuts, and that's going to be the amount of how many cases of each that we're going to buy. Okay. Now, for our constraints, okay, we want to know. It says up there, no more than 500 total units. Okay. So our total units can't be any greater than 500 total units. So I put this together, less than equal to 500 units. Here we had 12 units per mixed nut case, so 12x, and that's 20 for the roasted peanuts. Okay. You spend no more than $600. So again, less than equal to $600, and now we're looking at how much you pay per case. $24 X plus, where was it for the roasted peanuts, was 15 Y. Okay. And now, this is where I talked about in the first part of this section, where we had X is greater than equal to 0, Y is greater than equal to 0. I called them the common sense constraints. Okay. That plays a factor here. It doesn't say any more information about what the constraints are going to be or what we have to how many or how little of the case we can buy. But we have to use our common sense. Can you buy negative amount of mixed nut to sell cases? Okay? That can't go negative, and that's where the common sense constraints come in. X has to be greater than or equal to 0. Y has to be greater than or equal to 0. Since those can't go negative, I call these my common sense constraints. They're ones that you have to have. And that's just on to make sure everything's positive, everything fits in. Okay? So we have our objective function, we have our constraints. It's actually was on to be the next thing I said here. Find the objective function and the constraints. Now we have to graph the system, and then test the vertices to find the maximum profit. Okay? So let me erase some stuff here as I call up my graph. Okay, so here's the graph that we have here. Okay, the X greater than or equal to 0, Y greater than or equal to 0, they work out pretty easily. They're just vertical, horizontal lines, and like I said, just to show that everything stays positive. Okay, those ones, and now everything above and to the right of that is going to be where overlapping shaded area is. Now, the problem here for these two, okay, not really a problem, but let's look at it in slope-intercept form. I'm going to change the color so we can see the difference here. Okay, for slope-intercept form, for this top one, I have it as y less than or equal to negative 3 over 5x plus 25. Here we have y less than or equal to negative 8 over 5x plus 40. Okay, thinking about that, looking at what our graph is, y-intercepts of 25 and 40. Okay, most likely we're going to have to count by fives to get to fit all those in. -3/5, -8/5. The problem with that is when we start counting to do our slope, we're going to have to do some estimating. That's not always the best thing to do because then your lines are going to be a little off. And since our lines have to be pretty perfect, we have to know where those point of intersections are. This, using a slope intercept form, might not be the best way. Okay? Another way to graph these, we could use the x and y intercepts. Okay? We know we have our y-intercepts already, but now having our x-intercepts. Okay? Plug in 0 for y and solve for x and see what you get for those ones. The x-intercepts for this one here, our x-intercept would be 41.70, and the y-intercept was 0.25. There's our x-intercept and our y-intercept. Over here, for the bottom one, for the cost of this, we have 25.0 and 0.40 for our y-intercept for this one. That might make it a little easier to graph. Okay, because now you can just plot, you know how much you need for the y, what the scale needs to be, because you know it has to fit 40, it has to fit 25. For the x-intercept, same thing. You know it's not to fit 41.7, it's not to have to fit 25. So now you just have an idea of where your points are going to be and what your scales need to be. So I am going to count by fives going all the way up. Okay, it goes up to 50 there. 5, 10, 15, 20, 25, 30, 35, 40, 45, and 50. Now this is where, on your paper with your protractor, I'm hoping your graph is going to look much nicer than what I'm about to put on the board. Okay? For the amount of units, we know our y-intercept was 25, and our x-intercept was 41.7. 41.7, be right about there. With the protractor, again, you still have to estimate a little bit, but not so many times as the -3.5 to draw a line. Okay, so there's the 1 point there. Here we have x-intercept of 25, y-intercept of 40. Okay, we're going to go down here. It should be right about there. Like I said, hopefully yours with protractors look a little nicer. Now, the feasible region here, okay, we have less than, so these two lines here are going down. Our common sense ones are going up, so it's this area right in here. Now, a lot of these points we should be good with. We have 0, 0. We have 0.25, and down here we have 25.0 as our point. Okay? Now the problem here is this one here. Okay? We need to make sure we know what that point is exactly. Okay? Looking at it, 15, you might want to say it's 17, you might want to say it's 16. We can't go with that either or. We need to know what it is. So there's two ways you go about this. One way, you could set these two inequalities up as a system of equations and solve that system of equations. Whatever the solution is, would be the point of intersection there. Okay? Another way you could go about this is taking our equations or inequalities in slope-intercept form and graphing them. Okay? If you graph them on your calculator, adjust your window to fit the scale that we have for our graph here, then you can find that point of intersection on your calculator. Okay? So this is going to be up to you to decide what's going to be fastest for you. Doing the algebraic method on your paper to find that point of intersection, or using your calculator. I'll tell you now, to save some time, that point of intersection is 1516. Okay? It's good practice to go through there because I'm sure you're going to have to do it on an assessment. Okay? But now we have our 4 points. Okay? We want to maximize our profit here. Okay? X and Y are the amount of mixed nuts and roasted peanut cases that we're gonna buy, and here's the profit we make off of each case. So if we're not going through the work here, we have 18 times 0 plus 15 times 0. We have 18 times 25 plus 15 times 0. 18 times 0 plus 15 times 25. And then 18 times 15 plus 15 times 16. Okay, so going through that work, I have it here. This one's got a little bigger for me. The 0, 0 is pretty easy. We have 450 here. We have 375 here, and 510. And these are all dollars. This is how much profit. Oh, this should be 50. How much profit each one is. Okay, so looking at these values, we want to maximize our profit. The 15, 16. 15 cases of the mixed nuts. 16 cases of the roasted peanuts. Okay, so there's the example. Finding these point of intersections sometimes can get a little tricky. You're going to have to find techniques of how to get those exact points, because x-intercept, y-intercept, they're not that bad. Sometimes it will cross right at an exact point. Okay? But if there is a bigger scale and you're in between crosshairs, you're going to have to find a way to make sure you know exactly where that point is. You are not allowed to estimate. Okay? You have to make sure you know what that point is. Okay? So that's on the end of 3.5 linear programming.